Well, we're back, and today we're going to wrap up our discussion for two sample tests with means. We're going to do a problem with both a confidence interval and a significance test. We're going to see the connection and make the connection. So today our problem is going to involve the number of babies born to women in Venezuela and Colombia. So we're given this data up here. So we're given the data in this box. We're going to sample 100 women in each country. We have the mean number of babies born and the standard deviation. So here's how we do this. First, as always, we identify our mu1 and mu2. mu1 meaning the mean number born to women in Venezuela, and mu2 the mean number born to women in Colombia. We have our sample mean in our sample mean and our sample standard deviation in our sample standard deviation. The first thing we're going to do is we're going to set up a 90% confidence interval. This is all the information we need. We're going to do this on our calculator. Let's take a look at that now. As you recall, we're going to go to the calculator. We're going to stat tests. And remember what we look for? That's right. The two sample t int up here. Now again, this screen gives us lots of information. And so we need to input. This time, are we inputting data or stats? This time we're going to input stats. So let's enter there. And you see how that changes. So x1, we said was 2.53 with a standard deviation of 1.5 and a sample size of 100. Please make sure you can do this. Sample 2 had a standard deviation of 2.43 with a mean of 2.43 and a standard deviation of 1.4 and the mean size again of 100. Now, those look very similar, but what the calculations allow us to do is to figure out how similar they are. Pooled data, no. We'll go ahead and calculate the 90% level. When we do this, we can see our information corresponds, and we go from negative 0.24, we'll round to the nearest hundredth today, to 0.44. Okay, let's take a look at what this means. Well, you already know what it means, don't you? We are 90% confident that the true difference, remember, we are studying the difference for mu1 minus mu2. That true difference is going to be between negative 0.24 and 0.44. Pretty close, right? There's not a whole lot of difference in the two according to that. And as you can see, what special number is included in that interval? That's right, 0. Let's see how that relates to the significance test. Okay, so here we have a 90% confidence interval for the difference. Let's take and ask the next question. Is this difference significant is this at the alpha equals 0.10 level? Okay, and that's what we're going to find out here. Okay, so what are we going to do? Well, as always, let's set up our null hypothesis, our alternative hypothesis, and let's run the numbers on the calculator. Our job is going to be to interpret the results. Let's see what happens. Okay, so we've got our null hypothesis. Null hypothesis, always the same. Null hypothesis, no difference. In other words, mu1 equals mu2, or mu1 minus mu2 equals 0. Alternative hypothesis. In this case, we don't know who has more or less. So our alternative hypothesis here will simply be that they're not equal. That's going to be the alternative hypothesis. So the question is, when we run the significance test, if the null hypothesis were true, what's the probability of getting these results? And if that probability is higher than 10%, we fail to reject. Let's see what happens. Okay, we've got our sample mean for number 1 and our standard deviation. Sample mean for Columbia, sample standard deviation. That's really all we need to list here. We'll go ahead and run the calculator. Okay, do you remember what we're going to use now? That's right. It's going to be the 2-sample t-test. This time again, we're coming from data. From stats. And sure enough, you can see that those stats are already inputted in there. Now, the only difference here is that the alternative hypothesis will be not equal. Okay? We're not pooled, and we're going to have the option to calculate and draw. We're going to do both eventually, but let's calculate first. And you can see that we have a t-value of 0.48 and a p-value of 0.63. Wow, that's pretty high, isn't it? And so what is that telling us? Well, let's draw our graph and then we'll confirm it with the calculator. Here's our t curve. I know that 0 runs down the middle. 0.48 is about right here, isn't it? But because it's a not equal to, we also go to negative 0.48 and we do both ends. And when we shade both of those things together, we have 0.63 for our p-value. Okay? So therefore, what do we conclude? 0.63 is greater than 0.10, therefore we fail to reject. In other words, if it were true that women in Venezuela and women in Colombia had the same mean number of babies, we would expect these results about 63% of the time. And you know what? That's really good. We're going to take that, we're going to fail to reject, and we're going to move on. Let's review what that's going to look like on the calculator with their drawing. Okay, we're going to go back to our 2-sample t-test, stat tests 4, but this time, with all of that data, we're going to go to draw. Now, if that was a little fast for you, just pause, slow down, replay the video. Hit enter, and this is what we see. This should look something like what we just drew. And sure enough, it's coming in very nicely. You can see the two-tailed, what we call a two-tailed result. And this happens when things are not equal. Okay, now we've got our result from the test. We've got our result from the confidence interval. Really, the last thing we want to talk about in this unit is the connection between the two. And it's really as simple as the following. If the confidence interval includes 0, then the significance test will also include 0. And if the significance test also includes 0, we fail to reject because 0 is the null hypothesis. Remember, these 2-sample tests are always 2 samples of the difference. And what happens when the difference is 0? There's no significant difference when the difference is 0. Confidence intervals, significance tests. It's a beautiful thing. Take a look. Press pause and bask in the glory. Thank you for your basking. Continue on with your lives and have a great day.